Hello students, let's start class 6 chapter measurement of length and motion. See, in this chapter we are talking about measurements and we are talking about about motion. So start with the measurement part. Now what do we measure? Anything which we measure is called a physical quantity. Like we are measuring length, we are measuring mass, we can measure temperature, right? So anything which we measure is called a physical quantity. So for measuring a quantity, we need some units, and how are we going to measure? So in olden times, what we used to do, we used to have use body parts in order to tell the measurement. For example, here a figure has been given on the left side, which is a hand span, stretched hand, adult hand, finger, the distance between the tip of the thumb and the tip of the little finger. Now see, hand span will vary from one person to another. Why? Because the size of the hand of one person is different from the size to of the another person. But still these units were very easy. Why? Because they do not need any special instruments like a tape or an inch or a scale. You don't have to keep anything. You have a body, you use the body parts. So for reference, they were very easily you could convey to the other person. But exact value would differ. For example, one person measuring the length of this table might have 5 hand spans and another person would have say 6 hand span. So exact value was not, we could not find. So in order to avoid this type of differences, another system which was called the standard unit or the international system of units or the SI unit was developed. Now what are the advantages of these units? See, it is given here. Why these units were required? First was for uniformity, for accuracy, for clarity, and even see when scientists are doing some type of experiments, you need to have a exact value of say measures. If you keep on converting from one system to another, so sometimes it leads to errors. Okay, so this uniformity is very important. If I am having a cloth 1 meter length, it will give me that length which I can see at in another city or even outside India, right? So I know for 1 meter this much length will come. So that is why it is very important. See, when we are talking about the units, always remember, like for length it is meter, for mass it is kg, for time we use seconds, for temperature we use Kelvin. But other than these units, so now see, apart from these units, we also use prefixes. Like suppose I said that length we measure in meter, but is it possible for us to measure everything in meters? No, for very long distances we have to use certain prefixes, like I could have used kilo. Similarly, for a smaller I can use centi. So for every base units we are using prefixes in order to make measurements more easy way. So there are, see, this we have done even in maths, and the conversion comes even in physics. So you have to remember the base unit, and then every 10 means every 10 we keep on increasing, like deca, hecto, kilo, and the lower units deci, centi, milli. Okay, and their conversion generally comes. It is very important how to convert kilometer to meter or to meter to millimeter, right? So this is important. There was another unit in olden times called inch, which is given here. 1 inch measures 2.54 centimeter. So this you have to remember. Even today we use it. It is very commonly used. Though it is not a standard unit, but still it is commonly used. Okay. Then we come to how do we measure the length. So there are certain rules, regulations of measuring the length. When we are using a ruler and any object, first we have to keep that object on a flat surface. Okay, then we have to, ruler has to be straight, not like this inclined. And the third is the eye, the position of the eye. For this 1 mark question always comes, where do we have to position the eye? The eye has to be placed vertically above the point of measuring, the when we are measuring. It cannot be inclined, otherwise it leads to errors. That error is called parallax error. Okay, so you have to remember it. The positioning of the eye is really very important. Another way is, and second point is, that we have to mark 0 from the edge of the measuring object. We measure up to the last end of the object and we find out the length. Suppose if the scale is broken, so when the scale is broken, in those cases we find the suitable point from where we can measure. Suppose I say the scale was broken from here, I start from 2. I start from 2 and up to 10 I measure anything. So what will be the length of that object? The final reading minus the initial reading is equals to length. So this question also comes that if suppose we have a broken scale, what are the points we have to do? So this is the formula which you need to write, that the final reading minus the initial reading will give the length of that object and the position of the eye, which is very important. Okay. Then we come to how do we measure curved. Other than this here, I have discussed it in short form, whatever has been given in this book. Now we come to the curved line. Suppose this has been given, like if you want to measure something which has a curved and not a straight line. So we generally use with the help of threads, which is a very easy method. You can use pins, you roll the thread, or you can use a flexible tape, which everybody knows. Other than this, the thread thing comes in the questions, in the question paper. We take a thread and pins and we tie the thread and we rotate it and along the curved path. After that, we take the thread along the scale and the see from the starting point to the end point, and finally we are able to find the total length required. Like this can come, you have Diwali, you have to place your lights like this. How are we going to measure the length? Kitani length lagegi Diwali light mein? How are you going to measure? So for this, we can use a thread. Thread is easily flexible. So you rotate the thread, start from one pin, you put another pin and you keep on measuring it. At the end, keep the thread straight, keep a ruler and you measure the total length. Okay, now the second part of the chapter comes as motion. Now, how do you say motion? See, motion is something we always first have to understand what is the meaning of a reference point. We have to take a point, relative to that point, we have to say that the other body is in motion or not. Otherwise, it is not possible to say. I'm making a video, the phone is in front of me. So, I'm sitting, I'm not moving, the phone is not moving. So now I'm at rest, I'm not in motion when I take phone as the reference point. Now I get up for a glass of water. So when I'm taking reference point of the phone, my position is being changed. So I'm in motion with reference point to the phone. So I will be called as that I am in motion. Okay, now suppose I tell you next page. Suppose, see, in this, if you are traveling to Delhi, at one point the slab comes and it is written 70 kilometer. So Delhi, you point, you have to go somewhere. So that point is fixed. Now if I am standing here, so I am 70 kilometers away from Delhi. Now I start moving. I come to a point when it becomes 60 kilometers. So I am moving. That is why this distance is reducing. So, but the reference point of Delhi was fixed. So when I'm talking about Delhi, so I am moving because I'm changing my position. So let's take another example of a bus. I'm sitting in the bus. I have a friend sitting with me. The bus is moving, but am I moving? So again, if I take the reference point of my friend or the friend and me, reference to each other, we both are at rest. Because I was sitting at the same place and I can see my friend also sitting there. So I am not moving, my friend is not moving. Now when I suppose I am now standing out, I see the bus moving. So if I am taken as the reference point, I will say that the bus moved. Right. Similarly, if I am sitting inside and if I see the tree outside, so if I will see myself, what will I find out? That the tree is moving because it is changing the position reference to me. So whenever we are talking about motion, the reference point is very, very important. It is a fixed object or a point when we are talking about distance or movement. Is that clear? So this bus question is very important. It comes like if you are sitting in the bus, you see the tree moving. So you will see that for my reference point, the tree is moving. Okay. So you can say an object is said to be in motion if its position changes with respect to the reference point with time. So this is what is called the definition. How will you say that an object is in motion? So you have to remember the reference point and with time it is changing. Okay. So this has been explained here. Now we come to types of motion. Okay. So in this chapter we have to do the first is the type of motion which is called the linear motion. Linear means straight. Okay. Now, it can be horizontally, it can be vertically, it can be oblique, but it has to be a straight line. Apple falling down straight, eraser falling down straight, pushing of the box, marching. They are all linear. Why? Because they are in a straight path. Okay. But suppose I am putting a basketball. So the basketball goes like this. A part is straight and thereafter it is slightly curved. So that will be called curvilinear. This is called rectilinear. That will be called curvilinear. Okay. But in this book, it's only the linear motion which is given. It's not classified further. So if it is comes, so you remember straight line, it has to be linear motion. Now we come to circular motion. Any movement which is in the form of a circle. Now this is moving in the form of a circle coming to this point again. So this will be called circular motion. This is also moving in a circular part. Merry-go-round. The best example of earth rotation and revolution. Both are circular motion, but again there is a difference between rotation and revolution. Rotation is when it is rotating on its axis, the center being inside the object. But revolution is it is moving around another object. See, this is an example of rotation because you have to consider this as one whole and this acts as the axis. So it is moving like this, like a pen. Understood? So this is one whole. Fan, ceiling fan. That is an example of rotation. Merry-go-round, it is an example of rotation. Okay. So, but if you say a toy train which is moving in a circular path, that will be revolution because the train itself, the entire train is changing the position. Okay, so though they are circular motion, but if the classification comes for circular motion, there are only two, rotation and revolution. Now we come to oscillatory. Any object which moves to and fro, rest one side, coming back one side and coming back there. So that is called oscillatory motion. The best example being swing and the pendulum of the clock. Okay. See, when you are putting this you can do at home. You put this plastic scale and you give it a thrust. It starts moving up and down. From rest, it goes like this, then it comes down, then again to the original position, up, down. So this up, down, to and fro motion is called oscillatory motion. So in this book, there are only 4 types of motion has been given. Straight line, linear, straight line, linear. Circular, it is moving circular. This is also moving in circulars. This is to, fro, oscillatory. This is also up, center, down, up, center, down. Sewing machine. These are all oscillatory motion. So always remember, sometimes the examples are really very difficult. You have to observe whether it is actually a straight line or whether it is coming back like this. Then only it is oscillatory. Okay. See, I have already done the nothing else. Acha, another important thing which has been given, which is slightly different, is that how do we in the chapter, in the first part of the chapter, which was of measurement, how do you measure the a very thin, suppose the thickness of a paper, if you want to measure, how do you measure? The scale, you cannot use a scale. Scale does not have that minute uh, points. So how do you measure? In that cases, what we do is, suppose you have a paper, you have to take then many papers one above the another. You make a stack of paper, then you measure the height of the entire stack. So height of the stack divided by the number of papers will give you the thickness of one paper. So this formula generally comes, okay. And another is, suppose in case of vehicles, how do you find whether the how much distance the it has traveled? So this is also very interesting. We use a device called odometer. What is the principle of that device? See, this is a circle. So this entire distance is a circumference. So one turn of this tire is how much? The circumference. Circumference means that distance it has traveled. Suppose the cycle is there, one turn of the tire, you are moving the cycle forward. So when the full one turn of the tire it has moved, how much distance it will move? It will be equal to the circumference. So this principle is used to see the distance in case of vehicles. The number of turns of the tire multiplied by the circumference will give the distance the vehicle has traveled. Okay, imagine a circle, right? So this is the circumference of the circle. So now if you suppose open it in the form of a path and you measure the straight tire, you straighten the tire, so that is giving the distance. But when you are using the cycle or the vehicle, so every turn represents one circumference. So one circumference, next turn one circumference, one circumference. So you multiply the number of turns with the circumference and that gives the distance. So this is a very interesting way of finding out the distance in case of vehicles, and the instrument name is odometer. Okay, देखो, the types of motion of the ball on the roller coaster. See, this was a linear motion, then this was a circular motion, and this was again a linear motion. These type of questions also come. You have to divide the motion from points, right? From A to B, it was actually very straight, so it was rectilinear. Then again B to C, slightly curved, it was curvilinear. Then the full path, this was circular, and then this is again linear motion. Is that clear? Okay. Then there is also called periodic motion, which has not been given in this NCERT. The motion which repeats at regular intervals, that is called a periodic motion. The best example being rotation and revolution, right? After a fixed regular interval, it is repeating. So it is a circular motion, but it is also a periodic motion. Okay. I think this is the only things which are there in this chapter. Okay.